Good afternoon. Myself, Dr. Tanushree Ghosh, Assistant Professor from Department of Chemical Engineering, HIT Haldia. Today, my lecture is on Material and Energy Balance Computational Subject. Topic is Problem Solving from Recycling Operation. Let's discuss about recycling operation shortly. Now, what is it? It is a process operation dealing with a system where a stream leaving the processing unit is partly diverted and returned to be mixed with feed stream before entering into the same unit for reprocessing. That means from processing unit, when this product is leaving, from this leaving product, if a part of this leaving product is recycled over the processing unit and again mixed with this phase feed, just before entering into the same processing unit, that type of operation is known as recycling operation. Where we can see that when F is mixed with R stream, it is these two streams are bringing a new mixed feed stream having different composition. Now, when it is leaving as P dash stream and part is diverted as recycled stream, another diverted part is P, which is final product. Both P and R and as well as P dash have the same composition. Now, what is the significance of this operation? Firstly, it can increase the yield, then it can increase the purity, or it can increase the product, and also it can conserve heat, and by all these things it can improve any operation like drying operation, fraction, etc. Next, discussion on the problem on this recycling operation. Now let's see what is stated in this problem. Wet solid containing 75% water is mixed with recycled dry solid to reduce the water content to 50% before being admitted into the granulator. The solid leaving the granulator is fed to a dryer where it is brought into contact with dry air initially containing 0.3% water while in the dryer, the air picks up moisture and leaves with a moisture content of 6%. The solids leaving the dryer contain 15% water. A portion of this solid is recycled for 5000 kg per hour of wet solid sent to the granulator as fresh feed. Determine the following. Now, these are two questions. Amount of solid recycled that has to be determined, and the next question is the circulation rate of air in the dryer on dry basis. Now here all the composition as stated in the problem on wet basis. That is mass basis. Now how it is solved? I am going next slide. Here firstly a block diagram is drawn where all the given data are reflected on this block diagram. Two units are here involved, granulator and dryer. When fresh feed is entering as wet solid denoted by A, the total mass flow rate is 5000 kg per hour as given in the problem, and compositions are given here by wet percentage, 25% solid denoted by A, and water is B, percentage of wet is 75%, and then it is mixed with R stream, that is recycled stream coming from the leaving product of dryer, and here it is mixed at the point of A. After mixing, it is giving new mixed feed, that is F dash, the notation is F dash, and new composition is here developed, that is 50%, that is 25% solid, and here the 85% A. These two compositions are here when mixed, then giving the new composition 50% A, that is solid percentage. Now, when granulation is over, then we are getting new product P test. Now, due to granulation, size reduction is only occurred. Size, as because size is changed, that means no composition is changed. Total flow rate in terms of mass flow rate, it is not changed. That means A dash, P dash have same flow rate, same compositions. That's why you can write here P dash has the composition 50% A and 50% B. Next, when the dryer gives the product, the composition of A, that is percentage of weight of A is reached 85%. Obviously, rest 15% is B. Now, a part of this P double dash, which is the just product which is just leaving from the dryer, part of this is diverted as recycling stream, that is R, and the rest diverted stream is obtained as final product P. Now, what is the basis of this problem? You can take it as basis. Firstly, fresh feed rate is of 5000 kg per hour. If I draw the envelope around this endpoint and do the material balance on this envelope 1, overall material balance we can write in this way: F plus R equals to A dash. Putting this value of A, we can get an equation that is 5000 plus R equals to A dash. That is equation 1, which is formed. Next component, material balance of component A. What will be that? That is F into XAF plus R into XAR equals to A dash into XAF dash. Now XAF, XAR, XAF dash, these are the weight fraction of A component in F stream, in R stream, and in F dash stream. So when we are putting this value of all known values, that is F is known, F is known 0.25 weight fraction, and in R stream that is 0.85. As we know, P dash, P double dash, P and R, all these three streams have same composition. So we can write here with R 0.85 for XAR, and that equals to F dash into 0.5. XAF dash is 0.5. It is already given in the problem. So equation 2 is now formed. So both equations are showing what? R and F dash. These two parameters are unknown. If we solve these two equations, we can get the value of F dash, that is here determined 8571.43 kg, and R, which is determined, that is here 3571.43 kg, which is amount of solid recycled, and this is our answer of question A given in the problem. Now for the solution of B part, question B, if we draw the envelope around the dryer, then this is envelope 2, which is covering this drying operation unit, where we are observing two inlet streams, P dash and G1. G1 is the air by means of which moisture is removed from the wet sample P dash. So G1 is having initial percentage of water on wet basis, that is 0.3%. And when this air is leaving from the dryer, that is having 6% water, that is moisture percentage is increasing. And P dash, already I told that P dash, when it is converted into P double dash, that means moisture, after removal of moisture, the composition of solid, it is changed from 50% to 85%. So now here material balance on dryer, if you do that, that is envelope 2, focusing on envelope 2, here it is observed that if we find the tie component, which is here solid basically, and by doing this tie component material balance, that is for component A, we are getting what? P dash into XA P dash equals to P double dash into XA P double dash. Let's see what is it. P dash into the weight fraction of A 0.5, that equals to P double dash into 0.85. That is the solid component A balance over this dryer. After putting the value of all known values, that that is P dash known value, because P dash equals to F dash already told after granulation there is no change in mass and no change in composition. So that's why P dash equals to F dash, that is the mixed field which is just entered into the granulator, that is coming here 8571.43, and then that is into 0.5 except P dash, the composition was 50% solid, so that's why 0.5. P double dash is unknown parameter, and except P double dash is the composition, final composition of the product. So let's solve example, that is 85%, that's why here 0.5. Finally, from this equation we can evaluate P double dash value, that is the product amount which is just leaving from the dryer. Again, if we do the overall material balance on that dryer, that means on envelope 2, we will get what? That is P dash plus G1, that equals to P double dash plus G2. That means total inlet mass equals to total outlet mass. This is your overall material balance. Now P dash, P double dash both are already known. So P dash minus double dash, if you rearrange this equation, you will get P dash minus P double dash equals to G2 minus G1, which is giving this value. Obviously G2 you can write in terms of G1 here. Now if we write the dry air balance means here on this dryer, when air is entering, dry air is associated with few amount of moisture, that is 0.38%, and when it is leaving, that is attaining 6% moisture. If you do the only dry air, that is moisture free air balance, then we will get the equation, that is G1 into 1 minus 0.003, that equals to G2 into 1 minus 0.06. 0.38% was moisture percentage in G1 and 6% moisture was present in G2. So 1 minus this part is giving the wet percentage of dry air, and 1 minus 0.06, this is the wet fraction of dry air in G2. So if we balance these two equations, and again G2 is replaced by G1 from this equation 3, G2 equals to here written G1 plus 3529.41, it is replaced here in the place of G2, here it is replaced by G1 now. So putting the G2 value from equation 2, we are getting these two parts, and by balancing these two by balancing this part, the red one part, we are getting G1 value 58,204.305 kg per hour. This is the G1 but not dry gases. G1 is the air inlet flow into the dryer but not dry gases. But we have to determine the dry air flow rate on dry gases. So G dash, that equals to G1 into 1 minus 0.003. If we put that G1 value here, we will get G dash equals to this value. So this is your answer for question number B part. That's all. Thank you.